All right, so we're looking at 8.2 here, and what we're going to be studying, we're going to do 8.2 and 8.3 together. We're going to talk about the graphs of sine and cosine, and in 8.3 we're going to talk about how to apply the sines or the graphs of sine and cosine, to some real life examples. And yeah, let's take a look at sine and cosine graphs here first. I did give you a worksheet and asked you to draw the graphs of sine and cosine both on the same sheet. Now your sheet went from 0 to I think 720 degrees. I just clipped out part of that here. This is just one cycle, okay, for both sine and cosine, starting at 0, going to 360 degrees. Now remember, in radians, 0 is still 0 in radians, but 360 degrees is what in radians? Who remembers from last class? 1? Okay, 1 radian is 57.3 degrees, approximately. Yes. But 360 degrees is how many radians? Sorry? About 6.28 radians, yes, which is exactly what? 2 pi. Thank you. Yes. So 2 pi is exactly 360 degrees. The decimal would be about 6.28. That's very good. That's 2 times 3.14. Okay, good. And yeah, and 1 radian is 57.3 degrees. So you remembered some stuff from last class. Very good. Now, notice the graphs. Okay, let's take a look at sine first. Sine of 0 is 0. Okay? Sine of 90 degrees is 1. Now, you've seen this before. Maybe you did a physical science class. Maybe you remember that sine of 90 is 1. Maybe not. But anyways, you've seen this in other math classes as well, of course. The sine of 180 is 0. The sine of 270 is -1. The sine of 360 is 0. I highlight these points because this gives us an indication that there is some repetition going on, right? 0, 1, 0, -1, 0. What's going to be the next number here in that sequence is going to be +1, right? So this graph is going to keep going on like this. It's going to keep going. And you've drawn the 2 cycles so you can kind of see. Now, when you have both of them together, it kind of forms a double helix, right? That's sort of this, that's the shape. Now, why is that? Well, that's because cos x, and so in red here is cos x, and cos x is the same shape as sine. It's the exact same shape, except it's just a little bit out of phase, okay? It's a little bit shifted. It's shifted over. Because I want you to see that this point right here is sort of corresponds to this point on the sine graph. This one to this one, this one to this one, this one to this one. So it's just shifted over a little bit. If you take each one of these points, right, it's just shifted over. And how many degrees is it over? Well, it's over about what? About 90 degrees. So if we have a difference in angles of 90 degrees, we're going to start to run into some of the exact same numbers between sine and cos. So cosine starts at 1. Cosine starts at 1, and then it goes at 90 degrees down to 0. And at 180 is -1, and so on. So this is a repetition as well. This is a periodic function as well. And that little crash there. Okay, I think we're back. So sine and cos, very similar, the same shape of graph, but they're shifted a little bit. Shifted 90 degrees over. All right. So because of that repetition, that's what we call a periodic function, is a function where the graph repeats at regular intervals or cycles. So if you have periodic motion, that means you have the same motion every time, okay? If you're dribbling a basketball, okay? If you're just standing there dribbling a basketball, it's pretty periodic. The basketball comes up to a maximum height, and then you push it down to a minimum height, the floor, bounces back up to a maximum height, and so on. Down, up, periodic. Okay, they used to refer to magazines and different technical journals and stuff like that as periodicals. In the library, I think you'd still find the periodical section, which is like magazines and stuff that come at a regular interval, 3 times a year, 4 times a year, once a year, 12 times a year, whatever. So periodicals. All right. What about some of these other ones? Midline. Okay, what's the midline? Well, the midline is pretty self-explanatory. It is the middle line of any of these periodic functions. So if you consider sine and cos, let's take a look at the blue sine graph. This is your typical, starts at 0 and then ends up at 0 over one period. But the middle line here is the x-axis, isn't it? It's right through the middle there. And of course, the midline would have an equal distance from the midline to the top point as the midline to the bottommost point, okay? It's exactly in the middle. That's what the midline is. Now, if you have a graph that's shifted a little bit, like let's say you have a sine graph that's like this, okay? Well, that's a sine graph that's been moved up, and it's actually been moved over a little bit too, right? If I pick out, and let me just do this on the black graph, if I pick out maybe the one cycle of the sine graph, it might look something like this, right? You see that? So it looks like this sine graph maybe was supposed to be somewhere around here, okay? So it's been shifted up and over a little bit, and I didn't draw that quite right, but you kind of get the picture. So what does that mean? Well, the start and finish, or the start of a cycle and the finish of a cycle, which would look like a sine graph, would lead us to say, oh, you know what? This graph has been translated. It's been moved a little bit. And of course, it would actually look more like this, I guess, because this end has to be up and moved too, the same way. But notice that the midline, which normally would be the x-axis, or y equals 0, the midline is now up here. Okay, so here's your new midline. So midline can change as the graph maybe gets changed around a bit. So it's the middle. All right. The amplitude. Okay. This is a very scientific term. Okay. We talk about the amplitude of a wave, let's say, right? It's the distance from the midline to the maximum point, or the same as the distance from the midline to the minimum. That's called the amplitude. And hopefully this is making some sense, like ringing some bells maybe from science class before. Yeah?
So what is the trough?
Okay, so a trough would be this part right here of the graph, like if we're talking about a wave. Yeah, so this would be the crest, the peak would be the crest,
okay.
and then the trough would be sort of this part like this, where the, like a water trough would be shaped like this or whatever. So yeah, so we won't worry too much about crests and troughs. What we call the maximum points, so the highest point on a sine graph or cosine graph would be a maximum. The lowest point on a sine or cosine graph would be a minimum. But yeah, so the trough would relate to the minimum there. Okay, finally, what's the period? Well, the period is basically the length of a cycle. In science, it was called the wavelength. In math, we call it the period. Because what I want you to envision, and I'll show you a graphic in a second, is that this maps out motion of repeating objects, or objects that maybe spin or turn. And so the period would be the distance of one cycle, okay? The length or distance of one cycle. Now in these graphs, one cycle would represent for the sine graph a start point of 0 and an end point of 360, right? And so we have a period of 360 degrees. For the typical sine and cosine graphs, the period lengths are 360 degrees or 2 pi radians. All right, let me show you these graphics I was promising here. Let's see. Okay, this one's just for fun. This is just like kind of one of those like really kind of weird, sine, cosine graphics. It's kind of like, I don't know if this is supposed to like put you to sleep or something, but it's like, oh, isn't that neat? Okay, so very smooth, very... It makes you uncomfortable. Okay, fine. It's maybe not smooth and cool for you. All right. So here's another animation I want to play for you. Now think about this. And we're gonna, when we come across real life situations or situations where we could use some kind of sine graph to model behavior, think about this literally as a Ferris wheel. And this little point here that is being mapped on the graph here is you in the Ferris wheel. Okay. So as you go up, your height above the ground goes up. And as the Ferris wheel goes around, your height comes down, okay? So this is what the graph of your height above the ground, let's say the ground was down here, right? This would be the graph of your height above the ground, okay? Now there's different things that they're talking about here with this animation, but certainly this would be sort of an out of phase, sort of two graphs like that. This would be more like the sine and cosine graph, okay? So this is a little confusing, but these are 90 degrees apart, aren't they? And so if these are mapped, and can I slow this down? Playback speed, is this just for audio? That's just for audio. I can't do, can I do, I should know this, but can I do video playback speed?
Yeah, that is video.
That's video too? Okay. Let's see if you're right. Okay, nice work. So let's say that this one, let's say the green one is, oh, come on, don't go away on me. Let's say the green one is, hello. Oh, they're saying something really cool there. All right, so let's say the green one is the sine. Okay, so here's 0. Nope, 0 now. See, here it is, this ball. We're following it along. And -1, 0, +1, 0. And at the same time, oh, it's going away. At the same time, we have cosine being mapped. And notice that the cosine and the sine are the exact same y value at certain points. So whatever angle this is, you know, this is 45 degrees, and this is 45, 90, 135, so that they would be the exact same point. All right, which you see that on your graph up here. Okay, so they're the same point at this which is 45 degrees in there, 45, and they're the same point down over here, and they're the same point again, be up over here somewhere. Okay. So there's lots we're going to learn about sine and cosine. This is just sort of a brief introduction. All right, I think there's one more. Oh yeah, this one. Now this one's a little bit confusing, but this is mapping the sine and the cosine at the same time. And if you consider that, you see the lines that are connecting the mapping of the sine over here and the line that's connecting the mapping of the cosine, they're 90 degrees apart. See, they're forming a 90-degree angle. And as this rotates, one gets mapped on this plane and the other gets mapped on this plane. And you'll see that they're completely, if I can stop it, pretty close to 0. They're 90 degrees apart, and when one is 0, the other one is 1, or the other one is -1. So they're a little bit off like that. But anyways, yeah, this is very satisfying to me. I don't know why, but it's like I could watch this. So soothing. Okay, it's done. All right. Any questions though so far? All right, so here's some graphics. Again, this is for this lesson 8.2. Really, these terms are what we're learning and the periodic nature of these functions. So here's the key ideas: the period, the amplitude, the midline, right here. So I'll give you a moment just to look at this, and this should be the bulk of the lesson for 8.2. I will move to 8.3 here shortly, but here's your intro to 8.2. So I'll give you a chance to look at that for a second. Okay, so I do want to show you this on Desmos here. Here are your sine and cosine graphs. Now these are actually the same color. That's a little silly. Let me change that color. Let's make one of them blue. All right. So the cosine graph is in blue here, and the sine graph is in red. Now as you move along, see, as we go along to the right, they just keep going, bouncing back between 1 and -1. And they're always the same distance apart. And you kind of have this kind of a double helix structure a little bit, right? Not exactly, but kind of. Now it also is important to know that it extends in the negative direction as well. So it is a periodic function going both ways from 0. All right? Okay. Now going back to I just want to show you the textbook here. Okay, so graphing technology, certainly with the graphing calculators here, you can graph your y equals and sine and cosine, and you can see the graphs there. There will be some questions I'll require you to do here, just some introductory questions from 8.2. But I do want to move quickly to 8.3 and give you lots of time to do your homework, because 8.3 just continues on what we're learning in 8.2. So 8.2 is going to be questions number 1 to 8, but let's talk about 8.2. Wait, I should be on 8.3. Wait, give me a second here.